Yes, madam. Good morning, ma'am.
So, first of all, before we move into today's class, I would like to uh, revise, or I would like to know how far you understood the soil structure lectures. So maybe in the today's fish bowl learning, I would like to include AG 12, AG 13, 14, 15, 16, 17, 18, 19, 20, and 22. Okay, so once I ask the questions, please, anyone among these numbers I told, you can answer. And others also, if they do not answer, others also can answer. Okay. So first one is, what do you mean by type of soil structure? What do you mean by type of soil structure? Please quickly answer, otherwise I cannot go to the today's class. AG, yes?
It is according to the shape and arrangement of the pits.
Okay, so can you tell few types of soil structure?
Platy, prismatic, columnar, angular blocky, subangular blocky, granular, and drum.
Okay, so next person, what is the difference between columnar and prismatic? Columnar and prismatic, what is the difference? Quickly. AG 14?
Yes, ma'am.
Yeah, so what is the difference between columnar and prismatic? At least tell what is columnar structure. AG 12? Is AG 12 present?
Yes, madam.
Okay, so can you differentiate columnar and prismatic?
Columnar has rounded tops. Prismatic have rectangular top.
Okay, so what is the common feature between these two? Common feature or similarity between columnar and prismatic? AG 13? Are you there? AG 13. Absent? Okay, AG 16? 16 is not there. Then 17? Okay, anyone in the group? Can you tell the similarities between these two type of structure? Yes.
Vertical dimension is higher than the horizontal dimension.
Yeah, good. So that is the vertical dimension higher than the horizontal dimension. Okay. Then what is the class of structure? What do you mean by class of structure? AG 18? 18? Are you there? Okay, 19? Okay, AG26, can you tell what is class of structure? Yes, AG26, you are there. Can you tell what is class of structure? Hmm? So I think I have to ask everyone to unmute and on your video, then only I can ask you questions. Otherwise, you are hiding and I don't know what you are doing. So maybe come to the next class, you all have to, during the discussion, you all have to on the video. Otherwise, I cannot have this interactive class. Okay, no point in waiting. Uh, so maybe I'll move to today's lecture. So today we are going to study about soil water. Okay, can you see the screen?
Yes.
Okay, so soil water. So at the end of this lesson, that is when you finish about soil water, you should be able to tell the following. Okay, so that is differentiate soil water content and soil water potential. Then describe different methods to measure water content and water potential. Then differentiate components of water potential. Then describe soil water classification and level of soil moisture. Discuss soil moisture characteristic curve and factors that influence the moisture characteristic curve. And you should be able to explain what is hysteresis and factors influencing hysteresis. Okay, so these are the things you should know at the end of this lesson, not in this class. After you finish the soil water, maybe 2 or 2.5 hours lecture. So now we'll see what is soil water content and what is soil water potential. There are two terms you should know. So water content, as you all understand, the amount of water in a soil sample or in a soil is water content. And water potential, it is the energy status of water in the soil. That is water potential. So both are entirely different things. Water content is we are referring to the amount of water, whereas water potential is the energy status of water in the soil. The importance of water, I am not going in detail because you all know the importance of water for the plant growth, the nutrient uptake, microbial activity, for everything. Water is essential. So I am not describing that. Now we'll move on to measurement of soil moisture. How to measure the moisture content in the soil or the amount of water in the soil. So there are two types of measurement. One is direct method and the other one is indirect method. So direct method is the gravimetric method. So that is normally practiced and that is the actual correct measurement. And indirect methods are there. So there are many indirect methods are there. We'll be discussing only 3 of them. And these indirect methods are tensiometer method, resistance block method, and neutron scatter method. We'll study all these type of measurement. So first, the gravimetric method. So gravimetric means weight. Okay, weight basis we measure and interpret. Okay. So here in this is the basic method actually, and this is the correct method or accurate method. So it measures the mass of water. So how to measure that? You take samples from the field, then weigh the samples as it is. Then you oven dry it until you get a constant weight. That means you remove all the water from the soil. Then you weigh. So the difference between the two is weight of water. Okay. So the advantages of this method is it is a simple method and it is the standard method, because any other method cannot measure this accurate, and it is an accurate method. And also you can take samples from multiple locations and you can measure, and you can get an average value. And also it is comparatively an inexpensive method. But however, you need to have an oven to measure this gravimetric method, because you have to remove the moisture using an oven. And the disadvantages are it is high labor consuming, because you have to go to the field, take the sample, and so that high labor is required. And also time delay, because until you get the constant weight, you have to dry. So normally it will take 24 to 48 hours, even 48 hours for clay soil sometimes. So there will be a time delay. So that is one disadvantage. And the other one is it is a destructive method. That is, you have to take the sample from the field. So you are the normal soil condition is disrupted. So that's why it is a destructive method. Okay, it is not an in situ method. So those are the disadvantages of this method. So, so the procedure is explained here. You place an open container in an electrically heated oven at 105 degrees C until the mass stabilizes at a constant value, maybe 16 to 24 hours, even up to some cases it can go up to 48 hours. And what is the gravimetric moisture content? It is the weight of wet soil minus weight of dry soil. So that is the weight of water divided by weight of dry soil into 100. So normally we take the dry soil, not the wet soil, in the lower case. So that is gravimetric method. But in the field, when we apply water, we normally apply in terms of volume, how many liters of water, or maybe depth of water. So therefore, we have to calculate the volumetric moisture content, but you cannot measure directly the volume of water in the soil. So what we do is we measure the gravimetric water content and we convert that into volumetric water content. So what is volumetric water content? It is the volume of soil water per volume of soil. That is a centimeter cube of water per centimeter cube of soil. So that is the volumetric water content. Or it can be expressed in percentage. And the volumetric water is volume of water divided by volume of soil. And it is calculated after you calculate the gravimetric moisture content. If you multiply it by the bulk density of the soil, you can get the volumetric water content. One of the usage of bulk density is calculating volumetric water content also. So the volumetric water content is volume of water divided by total volume of the soil into 100. So that is the volumetric water content. And the gravimetric water content, which is the weight basis of water, is weight of water in the soil divided by dry weight of the soil into 100. So since the density of water is 1, the volume of water, the weight of water is equal to volume of water. Therefore, volumetric water content can be expressed as gravimetric water into bulk density of the soil. So if you know the gravimetric water content and if you measure the bulk density, then you can convert the gravimetric water content into volumetric water content. Okay, so that is how to convert gravimetric water content into volumetric water content. So if you have any doubts so far, you can ask. Otherwise, I'll go to the next slide. Okay, so the second method is, which is an indirect method, is neutron scattering method. Okay, so why we go for indirect method? Because this method, the gravimetric method, even though it is the standard method, it is a destructive method. So we want to find the moisture content where we do not take the soil sample from the field, but we measure it in the field itself. So it is the interaction of high energy neutrons and the nuclei of hydrogen atom in the soil. So actually this neutron probe, it is a tube containing a radioactive material. And this radioactive material emit fast moving neutrons from this radioactive source. So these fast moving neutrons will collide with the hydrogen in water in the soil and they will be slowed down. And the slowed down neutrons will be identified by this neutron probe and it will be counted. How many hydrogen atoms or how many neutrons are slowed down will be counted by this neutron probe. So the principle is the proportion of the slowed down neutrons is directly proportional to the amount of water in the soil. Okay, so that is the principle of measurement of water using neutron scattering method. So fast moving neutrons are thermalized by hydrogen atoms and the fraction of thermalized neutrons is calibrated against volumetric water content. That means, so for example, you saturate the water and you place this neutron probe in the soil. So what happens is when the soil is saturated, there will be more moisture content and slow down neutrons will be high and count will be high. So when we allow that probe in the field, the moisture content will decrease because of leaching and evaporation. So with time, we'll take the reading as well as we'll take some sample from the soil and we'll determine the moisture content by gravimetric method because that is the standard method. And then we draw a graph for water content and the reading. Okay, so by that we calibrate this instrument, and after that, at any time when you get the reading from the calibration graph, you can get the moisture content. So that's why it is called as an indirect method. Okay, so you measure the slow down neutrons, and if you have a calibration curve for different readings, what is the moisture content? Then at any time after that, you can measure the moisture content by using the reading. So that is the principle of this method. So here actual counts are not useful. Counts must be related with volumetric soil moisture content using appropriate calibration curve. So you have to take for different moisture content levels, what is the reading of these neutron probes. Then you can construct a graph and you can keep that graph with you. And then after that, when you irrigate the field, then you take the measurement and then you can find from the reading what is the moisture content in the field. So neutron probe is lowered into access tube to a desired depth. So this is there is an access tube. So you make a hole in the soil and you put the access tube, and then through that access tube you insert the neutron probe, and the fast neutrons are released from the probe, which scatters into the soil. So in this neutron probe, as I have already told, there is a radioactive element which will emit fast moving neutrons. So when the neutrons encounter nuclei of hydrogen atom of water, their speed is reduced, and the scalar or rate meter count of slow neutrons, which are directly proportionate to the water molecule. So when the water molecules or moisture content is high, the meter reading will be high. With the reducing moisture content, the meter reading will be reduced. So the moisture content of the soil can be known from the calibration curve with count of slow neutrons. So with earlier, before you start to measure, first of all, you have to get a calibration curve. During that, with different time interval, you have to take the reading of the instrument, as well as at that time you take a soil sample, put it into the oven, and you have to find the gravimetric moisture content, then convert it to volumetric moisture content, and you draw the graph. So the advantages of this method, there is large sphere of influence. That is, so for example, if you take only gravimetric method, maybe you will take a sample from here. But here, when you put the instrument, this instrument will cover a large sphere rather than a small sample. This instrument has a large sphere of influence, minimum soil disturbance during the measurement. So you just insert the meter into the soil and you measure. You do not take the soil sample out except for the initial stage. Then repeatedly sample same site and several depth is possible. So if you take gravimetric method, repeated measurement at the same depth or same place is not possible because you already removed the soil from that area. Then it is relatively an accurate method, and also it is useful for profile sampling. That means in different depths, you can measure the water content. But it has some disadvantages. This instrument is high cost because it is having radioactive element and also some detectors, and it has radiation hazard. So radioactivity. During radioactivity, there are rays are emitted, and if you are exposed to those rays, maybe health hazards occur, and it is not reliable for shallow measurements near the soil surface. So when you put on the soil surface, maybe these fast moving neutrons will escape into the atmosphere. So in the surface, the measurement is not reliable. So those are the disadvantages of this method. So that finishes about neutron probe. Now we'll move on to tensiometers. Okay. So here, this tensiometer mainly measure the soil water potential. So we'll be studying about soil water potential in detail in the next class. At the time being, you just know about the term. So tensiometer establishes equilibrium condition with soil water system. So what this is a tensiometer. So here actually it has major three parts. So it has a porous ceramic cup. So through this porous cup, water can enter into and out of this instrument. And also there is a tube containing water, and there is a vacuum gauge which will measure this or which will give the reading of water potential. Okay, so it is a very simple equipment. You can open this and you can fill the instrument with water, and then you can install it into the soil. Okay, so if soil moisture content is very dry, what will happen from this tube, water will come outside, and because of that there will be a vacuum created here, and that vacuum or that tension will be read by the tube. So at different moisture content, the tube will have different readings. So similar to neutron probe, you have to construct a calibration curve initially. Then after that, if you install this instrument in the field, you can measure at what time you have to irrigate. So this tensiometer is used by the farmers in many countries to find at what time you have to irrigate. Okay, so this is the porous cup act as a membrane through which water flows, and the tensiometer subject to negative soil water potential, causing water to move from the tensiometer into the surrounding matrix. So if we install it into a very dry soil, water will quickly move outside this instrument. And the movement from the tensiometer create negative potential, and that potential will be recorded in this vacuum gauge. And the tensiometer consists of a vacuum gauge connected by a tube to the porous ceramic tip, which I have already shown to you. And the tube is filled with water and is normally transparent, so that water level within it can be easily seen. This ceramic cup is, or the ceramic tip is permeable to water. It means it can allow water inside and outside, and it's normally transparent. So water level within it can be seen. And so water in the tube saturates the ceramic tip, and the tip is placed in contact with soil in the root zone. And because soil is normally not saturated, water is drawn from the tip into the soil. And when the water moves from the tube into the soil, a partial vacuum is created, and that is measured by the gauge. And this measurement is not a direct measurement of water content. So you should not confuse what is red is the water content. Actually, what is red is the water potential. So you have to draw calibration graph for that potential and water content. And then you can, after that, whenever you measure the reading, you can get the water content. So the level of tension in the vacuum is an indication of the amount of energy needed by a plant to counter the strength with which the soil hold moisture and extract water. Excuse me, I'm so cold. Disturbance. So if the soil is dry, it will absorb water strongly through the ceramic tip, creating great pressure, and it will give a higher yield. And correspondingly, the plant's root will need more energy to extract water from the soil. That means when the soil is dry, the root has to spend more energy to extract the water. So this is already I have discussed. The soil water tension is related to water potential, and this also is not water content but potential of the soil to provide water to the plants. So when the soil dries, the water tension increase and the water potential decrease. And as the soil water content increase due to addition from rainfall or irrigation, the soil water tension decrease and water potential increase. So the tensiometer allow us to monitor these fluctuation in soil water potential. So this tensiometer measure the soil water potential, and we calibrate for different water potential what is the moisture content. So then after we get a graph at any time, if we measure the tension or water potential, we can get the moisture content. Here again we can see the advantages and disadvantages of this instrument. So the advantages are continuous reading is possible. So once you install the instrument in the field, you can continuously take reading. And electronics and power consumption is avoidable. So, for example, if you have to do gravimetric method continuously, there is a lot of power consumption. But here, once you get calibration curve, then no need any power consumption. Then this is well suited for frequent sampling or irrigation schedule. So as I already told, once you install this, if you know at what potential you have to irrigate, then you can easily find at what time or on which date you have to irrigate. Then minimum skill required for the maintenance. So this is just a tube. You have to fill it with water and install it. So not much skill is required. Not affected by soil salinity. So some instruments, especially the instrument we are going to discuss next, that will be affected by salinity, the measurement, but here this is not affected by salinity, and therefore we can use it even salt affected soils, and it is a less expensive instrument compared to neutron probe. It is a very expensive instrument, but this is a less expensive instrument. Then the disadvantages or drawbacks of this instrument, it requires calibration. So all the three indirect methods actually require calibration. Then limited soil suction range. So using this instrument, only less than 1 bar suction level can be measured. If the suction level increases beyond 1 bar, we cannot measure moisture content using this instrument. So this bar and suction we'll be studying again in the next class, so don't worry about that now. Then relatively slow response time. It will not take much time to measure. Once you get the calibration curve, it is easily you can calculate, and requires intimate contact with the soil. So when you install it, you should be very careful. There should be intimate contact with the soil and the instrument. If you do not install it properly, maybe the measurement will be inaccurate. Then require frequent refilling to keep the tube full of water. So since when you install this instrument in the dry soil, the water in the tube will quickly reduce. So you have to refill again and again to keep the tube with water. So these are the drawbacks of the centrometer and advantage as well. So the third method, or the third indirect method, or the fourth method is electrical resistance block. So this is also similar to the tensiometer. You read some measurements, then you do take a calibration or get a calibration curve, and then using the calibration curve, you can measure the water content at any time. So this, what is in the figure, is the electrical resistance blocks. So this electrical resistance block consists of two electrodes enclosed in a block of porous material. So here there is a porous material. So again, this is a porous material, which means it will allow water to come inside and outside. And within this porous material, there are two electrodes inserted within this porous material. So the block is often made up of gypsum, although fiberglass or nylon is also sometimes used. And the electrical resistance blocks are often referred to as gypsum blocks because this block is made up of gypsum, and sometimes just moisture blocks. They are also called as moisture blocks. And the electrodes are connected to insulated lead wires that extend upward to the soil surface. So here the electrodes are connected, and it is connected to a meter. So the resistance block works on the principle that water conducts electricity. So when properly installed, the water suction of the porous block is in equilibrium with the soil water suction of the surrounding soil. So once you install it and allow some time, then the water suction or water potential inside the block and the outside soil will become equilibrium. And as the soil moisture changes, the water content of the porous block also will change. Okay, so after you put the porous block for some time, the moisture inside the block and the moisture outside the block will be in equilibrium. Then the electrical resistance between the two electrodes increases as the water content of the block, porous block decreases. So you know, when moisture content increase, electrical conductivity will increase, whereas the resistance will decrease. But when moisture content decrease, electrical conductivity will decrease, but the resistance will increase. Okay. So the block's resistance can be related to water content of the soil by a calibration curve. So similar to the earlier method, you have to equilibrate, put the porous block in the soil, and you have to equilibrate the moisture content and the porous block. Then After that, you have to take reading of the porous, these resistant block reading at different time, and when you are taking the reading, you have to take a sample and put it into the oven, and you have to find the moisture content, and you have to draw a calibration curve, that is moisture content versus reading. Then using that graph, after that, at any time, just with the reading, you can get the moisture content from the graph. So this is how you install the porous block. So you can have multiple blocks also at different depths, and you can measure at different depths what is the reading. Okay. So the advantages of this method is it is again a non-destructive method. It also requires little maintenance and simple and less expensive compared to neutron probe. And the drawbacks or disadvantage, it requires calibration and salinity can affect, because when you dissolve salt in the water, the electrical conductivity will be influenced by the salt. So if salinity is there, the conductivity or resistance is because of the salt. So that will interfere with the measurement of moisture. And the other disadvantage is since it is made up of gypsum can dissolve in water. So if you install it for a long time, it will dissolve and disappear from the soil. So in that case, you require replacement of the block. So that is the one of the disadvantage of this instrument. So both tensiometer and resistant block methods are indirect methods as neutron probe. So you have to draw a calibration curve for each of these instruments in the field. That is potential versus moisture content for tensiometer and resistance versus moisture content for resistance block. Then you can measure moisture content indirectly. So that's about the measurement of soil moisture. So now if you have any questions, you can ask. Yes. Are you alive?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, so you don't have any questions? Hmm? Did you completely understand or you didn't understand anything? Both in both the extreme, you will not ask questions.
Completely understood.
Completely understood. Okay, so definitely tomorrow, next class, I have to have a poll and see whether 100% is taking correct. Okay, anyway, we'll move on to the next section. So it is about the soil water classification. So there are three types of water in the soil. One is gravitational water, capillary water, and hygroscopic water. So gravitational water, normally we commonly it is told as drainage water. So what is that drainage water? So it is the water that can move out of the soil due to the forces of gravity. So when you saturate the soil with water and allow to some time, due to the force of gravity, this gravitational water will drain from the soil. And this water is not useful to the plant. It cannot be used by the plant. And it is harmful to plants because it removes the nutrient from the soil. And also, if you do not provide enough drainage, then it will affect the aeration of the soil, and the root respiration and microbial respiration will be affected if you do not remove the gravitational water from the soil. And the next one is the capillary water. So this capillary water is held within the capillary pores or micropores by surface tension forces. So the water held in the micropores by surface tension forces are capillary water, and this capillary water is available to the plant, and the amount of capillary water available in a soil will depend on the texture, structure, and organic matter content of the soil. So normally, for example, clay soil will have more capillary water because it has more proportion of micropores. And if you take structure, so can anyone tell which kind of structure will have more capillary pores? You have studied different types of structure. So which type of structure will have more capillary water? Yes?
Granular structure.
Granular structure.
Yeah. In granular, and what about crumb structure? Crumb structure? Yeah, in both the granular and crumb structure, you have more capillary water compared to other type of structure, because in other type of structure, the micropore proportion of micropores is very less. For example, if you take platy structure, it is like a wafers, so there is very less chance of capillary pores, and if you take a columnar structure, again, they are very tightly held, and the proportion of capillary pores is less. So granular structure, and also to some extent the cubic structure also have capillary water compared to other type of structure. And what about the organic matter content? Will it increase the capillary water or reduce the capillary water? Organic matter. Can anyone tell? Increase. Okay, what is the reason? What is the reason why organic matter increase the capillary water?
Organic matter has more spore space.
Organic matter has more space. Organic matter has more pore space. Or when you add the organic matter to the soil, it will improve the soil structure formation. Okay? And because of that, the soil structure formation, there will be more micropores created, and that will improve the capillary water. Okay? But organic matter can increase the water holding capacity also. But as far as capillary water is concerned, these capillary waters are held in the micropores. So by adding organic matter, we can increase the proportion of micropores in the soil. Because of that, capillary water can be increased. So now the third type of water is hygroscopic water. So this water forms a very thin film around the particles and attached very tightly to the soil. So that is attached by adhesive force. So the water is adhered to the surface, and the water that is very close to the surface is called as adhesion water, that is adhered to the surface. And the in between is cohesion force, is the cohesive force between the water molecules help to hold the water in between. Okay, so the water that is held in the solid particles by adhesive force is called as the hygroscopic water, and this water is not available to the plants, but maybe it can be available to some microscope, not for microbes, not for all microbes. For some microbes, this can be available, but for the plants, this hygroscopic water is not available. So that is about the types of water in the soil. Next, the level of water in the soil. So we use three terms to describe the level of water in the soil. So first one is saturation point, then field capacity and wilting point. So saturation point is the all the pores in the soil are filled with water. So the moisture point at which all the pore spaces in the soil are filled with water, that point is called as saturation point. So can anyone tell at any incidences where you can get this saturation point? During which time you can get saturation point? In a field, in a cultivated field, at during which time you can get saturation point? All the pores filled with water. Yeah, immediately after irrigation or immediately after a rainfall, all the soil pores will be filled with water. Then field capacity, it is the maximum amount of water left in the soil after losses of water to the forces of gravity. So after a heavy rainfall or after a heavy irrigation, if you allow to drain, the gravitational water will drain and only the capillary water will be in the soil, and that during that time, if you measure the moisture content, that is called as the field capacity. Okay, so field capacity is the maximum amount of water left in the soil after loss of water to the force of gravity. So after you remove the gravitational water, what is the maximum amount of water in the soil? That is field capacity. And the wilting point, the point at which the plant can no longer obtain sufficient water from the soil to meet its transpiration needs. So that means after the wilting point, or you saturate the soil and allow the soil to dry, then all the gravitational water will drain and it will reach field capacity. Then if you further allow the soil to dry, there will be a point come where the plant cannot obtain any water from the soil, and that point is called as wilting point. So that is wilting point. So if you allow the soil to dry up to wilting point, the plant may die. So that is the wilting point. So that is all about soil water content, and we have to talk about soil water potential. Maybe we can start soil water potential in the next class. And so before we close, if you have any questions you can ask, or if you have any doubts which you did not understand, you can ask. Yes. So when are you coming to the faculty? Yes. When you all coming to the faculty? You don't know?
Yes, ma'am. We don't know about.
You don't know. So maybe another 2 weeks time you may come. After your seniors complete your immediate seniors. Once they complete, we'll be calling you, and maybe we have to have some practicals. Then you have to sit for your exams. Okay. Did you ever come to the faculty? No? Yes?
No, ma'am. No, ma'am.
So, do you know your seniors? Hmm? Do you know your seniors? Yes or no?
Yes, ma'am.
How do you know? You got ragging?
No, ma'am. Friends are.
Mm-hmm.
My friends are here.
Friends.
Yes, ma'am.
Okay, very good. So maybe during your lifetime you may not see them. So we want to send them and we want to call you. So you may not be able to see them if Corona is like this. Okay. Anyway, so you don't have any questions, huh? Okay. So in that case, I'll stop here and you can go to the next class. Do you have another class now? 10:30?
Yes, ma'am.
You don't have a break in between? Always you are in break, no? Always eating, talking. Why another break, huh? Okay. Okay, so thank you. Maybe next class, maybe another lecturer will take, maybe Abhirami will take, I don't know. Because she may not be available for some time, so she want to cover her section first. So maybe next week, Abhirami will start the chemical properties. Then again, I'll take after she finishes, so in between I'll take. And also, you have been given term paper, isn't it?
Yes, ma'am.
Yeah. So please take it as a serious thing and study soil, because all this time the term paper was not like this. So we want to involve the students as student-centered learning. So you can touch the soil, feel the soil, and study the soil. That only will help you to work in the field. Okay, so please take it as a serious thing and do the practical. The paper. Okay, thank you. I don't want to waste your time. Thank you. You can leave now.